Welcome to the video for lesson 10.3. Please record the learning target. I can use relationships of arcs and chords in a circle. So we are going to be dealing with arcs and chords and how they relate to each other in a circle. So we have only one vocabulary term, that's chord, and we should be familiar with a chord because we've talked about it several times in class, but let me just draw a circle really quickly here. And the center of the circle is how we name the circle. So if it was called circle C, it would look like that. And then a chord has its endpoints on the circle. Okay, so an endpoint would be an actual point on the circle. And let's just call that X, Y. So if there are multiple chords in one circle, they may have a relationship to each other, or they may have a relationship to the diameter, or to an arc. So we need to pay attention to the next few things here. The theorem 10.3 is going to be important, 10.4, as well as 10.5 and 10.6. So while you're filling this information into your notes, you also need to record this information in your mind because you're going to be using these theorems in the next few examples as well as on the practice set. So let's go through 10.3. Theorem 10.3 says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if the chord itself is congruent to another chord, let's just call it AB. So if XY and AB are congruent to each other, then that means the two minor arcs, that's the part of the circle, right? The circumference. An arc is the distance on the circle, right? So those two minor arcs are going to be congruent. So if the segments AB and XY in the circle are congruent, then that means that XY, the arc, is going to be congruent to AB, the arc. The minor arc AB is going to be congruent to the minor arc XY there. So it has to be in the same circle, or it has to be in congruent circles, okay? So keep that in mind. It doesn't work just any time. Okay, let's take a look at theorem 10.4. It says, if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So we need to consider the one chord. If that one chord is cutting another chord in half, and it's perpendicular to it, then that one chord is a diameter. So the initial chord that we were talking about happens to be a diameter if it's a perpendicular bisector of some other chord inside the circle. That's a tricky one. We're going to look at that several times in our examples. All right, let's look at 10.5. Theorem 10.5 says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. And let's go ahead and draw a diagram to demonstrate that. This will be a tiny little example over here. So a diameter goes through the center. It's the longest chord of the circle. And if that diameter is perpendicular to a chord, then the diameter is cutting the chord into two congruent parts as well as its arc. Okay, so not only is this chord being cut in half, but also this piece of the arc and this piece of the arc are going to be congruent. So if that's too tiny for you, we're going to take a look at a couple of examples using that theorem. And you'll have some practice problems related to that theorem as well. Last theorem in this section says in the same circle or in congruent circles. Remember, congruent circles are those that have a radius that is the same. Two chords are congruent if and only if they are equidistant from the center. So we'll look at a couple of examples of those as well. So to begin some example work, let's take a look at example 1. Okay, look at the diagram, please. It says that in the diagram, circle A is congruent to circle B. And I can tell that that's the case because I see a congruent marking on the radii. each radius has a single tick mark, which means that the circle A is congruent to circle B. It also tells us, the information that we're given here says that chord CD is congruent to chord EF. Here's a chord EF, it has 2 tick marks on it. Here's the chord CD, it has 2 tick marks on it. Okay, so if the chords are congruent, then we need to know something about the arcs, because they're asking us to find the measure of arc EF. Now, the measure of arc EF is going to be between E and F, but on the edge of the circle. And if this one right here, arc CD, is 140, and the chords are congruent here, then that means this arc over here is also 140 degrees. So the measure of arc EF is going to be the same as the measure of arc CD because the chords were congruent. Okay, so if you recall from theorem 10.3 that we wrote down above, that theorem says that if 2 chords are congruent in the same circle or in 2 congruent circles, then the arcs are congruent. Okay, so that's one of the things you're going to need to remember. And we already indicated that those 2 circles were congruent and that the chords CD and EF were congruent, so therefore the arcs on with those endpoints, the same endpoints, are going to be congruent as well. So you have some practice on your own problems here to try, and it looks like in circle K there are 2 congruent chords there. And remember, if the chords are congruent, then those arcs are also going to be congruent. So we have this arc is going to be congruent to this arc, since the chords are marked congruent and we're dealing with just the one circle. All right, please try these problems and then we'll check in and see how you did on those. The last thing on this page to do is just to cross out example 2. I don't need you to do example 2. We're going to skip that one. So turn your paper over, please. And since we skipped example 2 on the front side, we're also going to skip this practice problem on the back. Let's just move on to example 3, where we're going to use a diameter. In circle A, find the lengths of CJ. Okay, so we have to find the length of CJ, which isn't a chord, it's not a diameter, it's not anything special, but we need to find that segment length. And then we also need to find the length of segment AK. All right, so I want to point out a couple of things. It says here that chord BC and chord FG are both 16. Okay, so I'm going to put those in purple. So FG is 16 and BC, this entire length here, which I'm just going to leave it half purple, half green there. And we'll just have to keep in mind that FG and BC are both the same length. So we have 2 congruent chords. And we also know that the segment between A and J is 5. Okay, so it tells us that right here. Now we have to find the length of CJ and we have to find the length of AK. I'd like to start off by solving for segment AK. We need to use theorem 10.6 to solve for AK. Let's read what it says. You can write this in your notes page. Theorem 10.6 says 2 chords are congruent if and only if they are equidistant from the center. All right, so because these 2 chords are congruent, I know they are equidistant from the center, and equidistant just means the same distance. So the chord BC is 5 units away. Remember they said that right up here. And that means that if that one's 5 units away, then that means that AK is also 5 units away because the chords are congruent. All right, so looking at the segment CJ, I need to find out what that green segment is, and I want to remind you that 10.5, our theorem 10.5 says that if a chord and a diameter are perpendicular, then the diameter is going to bisect that chord. And look at what we have right here. We have a perpendicular mark. Okay, so the diameter, since it's perpendicular to BC, this chord, that means that the diameter is cutting BC in half. Well, what's half of 16? Because BC was 16 in length. So BC equals 16. And so therefore, 3 dots there, CJ is going to equal 8 because the diameter is cutting BC in half. So as I said at the beginning of this video, you need to remember the different theorems. You may not need to memorize the actual number, but you need to know them as rules, okay? So you can think of theorems in geometry as rules, and these rules have been tested and, proven to be true, so that's why we call them the fancy name theorem. So basically what we have here is BJ is going to be congruent to JC. Okay, those two segments of that chord are congruent because it's been cut in half by this perpendicular diameter. And again, that's something you'll want to remember for future practice problems. All right, the last thing you need to finish up is practice on your own, numbers 5 and 6. And in order to do that, I want to give you a little hint. It's asking you to find the measure of arc BD if the measure of arc CD in the diagram is 4x. So if CD is 4x and BD is 2x plus 40, you can solve for that because, as I mentioned in the previous problem, ED, the diameter, is cutting this chord in half. Okay, so it's made this segment congruent to this segment, but it's also done the same thing to the arcs. Okay, so the arcs on the edge of the circle related to that chord are going to be congruent also, and that's part of that 10.5 theorem. So you may want to refer back to that, but 10.5 theorem says that that diameter, if it's perpendicular to the chord, not only cuts the chord in half, but also cuts the arc in half. Okay, so you're going to set these things equal to each other. Once you solve for x, I need you to plug it back in to the length for BD, right, the expression for BD, so that you can find out what the measure of that arc is. All right, and then also you need to find the length of GK if BC and FG are 20. So the chords are 20, and what is the length of just half of it? Okay, so that's what you're doing for number 6. All right, thanks a lot, guys, for paying attention and for watching. We'll have some questions in class.